Welcome, everyone. This is Practical GraphQL on Android. My name is Kevin Schultz. I'm a software engineer at Facebook here in New York. And I'm going to start off with what I'm sure is an uncontroversial statement at an Android conference, that you should design your system to make your Android engineers more productive. And this is not just pandering. It's because we have a world where we have three stable platforms. You need a web app, an iOS app, an Android app. You're going to have more engineers focused on those things than your backend. So working your system to be productive for those engineers makes a lot of sense, and GraphQL is a reaction to that idea. So today I'm going to go over what is GraphQL and why should you care. This is not really a talk about what Facebook does with GraphQL. It's a talk about what you could do with GraphQL in your apps at home. I will do a brief introduction to GraphQL concepts and the structure of the language, and also a brief overview of what you can use for backend GraphQL APIs. You can't really use it without a backend. But the meat of the presentation is really how do you use GraphQL on Android in an open source way today. And then we'll take a look at what should the future of GraphQL in the open source community be. So let's start off with what is GraphQL. And I think it's best to look at the motivations that led us to build this thing. So the first true fact is that you can release your server anytime you want. You can ship it every hour, and you fully control it. Any technology you want, any hardware you want, you own that completely. Meanwhile, client apps, whether they be iOS or Android, take hours to release, days to release if you have a review process. You will have many app versions in the wild at the same time. It's only a question of how many. And there's a long tail of users that simply will never upgrade. Maybe they don't have space, maybe they don't have auto update on, whatever the reason. If you have a broken version of your app or even an old version of the API you no longer want to support, it basically is going to be in the wild forever. Second motivation is around latency. Mobile devices, even as we get better bandwidth, still have the physical limitations of latency. So the best scenario is if every time you open the screen, you do exactly one request. That's the minimum amount of round trips you could have. Many of us don't have the benefit of APIs where we can get everything in one request. We need to make multiple. So ideally, you're sending concurrent requests. You're still blocked by the slowest one, but you can get some information back faster. But this makes your UI much more complicated. These things will return in different orders. What happens when only one of them fails? So you have to add logic to your app that adds complexity that really should be better suited on the server. And the worst case scenario is if you have dependent requests where you don't start the second one until you get the response from the first one, you're really slowing down the interactions for a user. It's a poor experience. So we really want to work a system where we have a single response, single request and response every time. And finally, there's a big motivation around bandwidth. Everyone has API responses with this many fields, probably 10 times this many, and you actually only care about 2 of them. So you're wasting your user's network, you're wasting your user's battery, you're wasting your own traffic in your data center, and the CPU time to prepare it. It's wasteful on both ends of the contract. So you definitely don't want to be doing this. So thinking about these things, we came up with an approach where the client should define the response. The software engineer building the client is in the best place to identify what they need to display their screen. We want to make exactly one call every time what we're displaying changes, and each of those calls should fetch only what it needs, no more, no less. And we want to push as much complexity onto the server as possible. Even if the total system is more complex to support this behavior, you control the server completely, and that's where it's better to have this kind of code living. And this final one, which I don't think was one of the original motivations of GraphQL, is that specifications enable productivity. They're a little bit constraining in that you have to live within the spec, but they're also enabling in that you can build tooling on top of it, and you can have libraries that interact with each other very cleanly, and there's less configuration if there's a specification. So GraphQL, as it's implemented today, is very well specified. A quick question that I'm sure I will get is, why not REST? I can do all of these things with the right REST API, and that's totally true. But I would argue that as I've experienced it at a couple different companies, REST APIs are really ad hoc RPC, where you make a call that gets multiple resources back, or it's really tuned around a particular operation. And these are really RPC type protocols living on top of the REST paradigm. I'd also argue that even if you do all of the work to get perfect APIs in a REST world, you're spending a lot of time maintaining the backend. I was doing that, building backends for front ends for a while, and it's very low value work. It's just getting the right JSON response for different things, and it's not exactly where you want engineers' time to be spent. And although you can have the client define what the responses are on REST APIs, this is often called content negotiation, I found it to be rare in practice. Only the best REST APIs have this. You'll see it on Etsy's and GitHub's, but very few people are building this from the beginning. And finally, although REST is built on top of standards, in general, it's loosely specified. How many times we stood around a whiteboard arguing about what is or is not RESTful? And that's only happening because we don't have a very clear specification for what is or is not REST. So Facebook, this is a we that does not include me because I did not invent this, but the people at Facebook that came up with GraphQL built something to address these concerns, or at least tried, and in our experience at Facebook, it has improved on many of these aspects. So what exactly is GraphQL? Practically speaking, it's an interface definition language. It's not the first one. I think JSON, you even can consider, has an IDL of its own, but GraphQL is one. It's language agnostic. It doesn't matter what your server is. It doesn't matter what your client is. GraphQL is the middle language that they both know how to speak. There's a draft specification out for comment. I think we just exited technical preview. So if you love white papers as much as I do, it's out there. There's reference implementations. Right now, the major one is in JavaScript, open source from Facebook, and that is spec compliant. And there are tools, both open sourced from Facebook and also built by the community around the GraphQL ecosystem. And there's really some key principles driving GraphQL. It's product-centric, and by that I mean it's a language that's built for the layer between front-end and back-end at the product, not between services on the back-end. So it's not like a Thrift competitor or something like that. It's actually for your front-end communicating with your back-end right at that interface. It's client-driven, as I mentioned. The software engineers building the client define their API. It's strongly typed. We truly believe that this reduces errors and pushes those issues earlier in the build cycle. It's introspective, which enables tooling. So that basically means you can query the schema itself to find out about the schema. And that also helps with tools. So speaking of tools, probably the best place to start looking at GraphQL is one of the open source tools called Graphical. And this is an interactive, basically web-based IDE for using GraphQL. You can try out different queries in it. You can execute them, get response. You can see documentation. And this all works as soon as you have any kind of GraphQL API. So in this case, you can see we're using introspection to actually autocomplete as you're typing. You can see the documentation coming up in the browser. And these are all the kind of things that are enabled when you have a well-specified system that has these properties. So it's kind of like Swagger, but it works out of the box and has even more features. So that's very, very useful. So basically all of GraphQL builds off of types. These are probably relatively familiar to you from considering them like resources in your API. The syntax is pretty straightforward. We flipped the type and the name on fields relative to Java, but pretty common in a lot of programming languages. And these are the types defined on the server that everything starts from. The fields that you have in your types can be simple primitives, as you'd expect. They also can be enums, and they also can be other GraphQL types. You can build a hierarchy of GraphQL objects, and that is really useful in defining our APIs. Fields themselves have a few options, so they're nullable by default. You can enforce non-null with an exclamation point. You can return a list of either primitives or types with the array symbol. And then when you dig into, this is a basic query. So this is what the client-side developer is writing. And in this case, we're looking for a particular film from the API. We have its ID, pretty self-explanatory. And we execute that. Oh, and we're looking for these two fields and only these two fields, the title and the ID. And we execute that. We get a response back very much in the same shape as the query we defined. So the query is actually describing the form of the response you're getting back. You can, of course, make queries a little more complicated. Your app's going to have many queries, so naming them is a good strategy for keeping everything clear. We also allow you to pull back lists of objects. It's not just single objects. So in this case, I want to get all the films. And again, I'm only pulling those two fields I'm interested in, even though the film type has dozens of fields. And when you execute this, you get a JSON response with an array of items. So I already showed you one example of argument, but I think this is where the advantages of GraphQL start popping up. So of course, one argument's not bad in REST. You can put it in a path segment. But what do you do when you have multiple with different layers? Well, you start appending query parameters. In GraphQL, we are embedding all of the different arguments at any point in the query, so you can have many different layers throughout. And of course, this gives you the response you'd be expecting where we have the units we're looking for. Variables are a twist on arguments. It's basically, rather than hard coding the actual value that you're looking for in the query, you put some variables in there, and then you can fill them up, in different values as you're using them. And the actual variables are sent as a separate object, which is nice. And then finally, fragments are a nice construct. So if you noticed, we had been using the same two fields over and over and over again. 2 fields is nothing, but when you have 10, this becomes tedious. And you could imagine using the same 5 fields for a particular view in many different places in your app. And then all of a sudden you want 6 fields. Do I go back and add them everywhere? No, that's kind of wasteful. So in interest of not repeating yourself, we allow you to define a fragment, which is a subset of a type. So if we're only interested in these 2 fields, we define with the fragment keyword, particular installment. And this is only on a type. So this is not just these fields anywhere. It's a subset of a type in the context of that type. And so then we can reuse this over and over. And if we want to refactor it, we only have to change it in one place. Your question? I'll do them now if you want.
What do you mean by installment?
It's just I'll go with it's a business logic. Like this could be foo, this could be bar. This is basically just the name of your fragment. And that's actually a good point. The name of the fragment that you're using on the client side is defined by each app itself. The version, whether it be iOS or Android, these don't actually show up in the schema anywhere, but the types do belong in the schema. So film is a type that the server knows about, and that's on the schema there, but your fragments as the client are basically private to your own usage. And this will actually show up in a couple more slides. I'll make that clear, but I appreciate the question. So again, the 2 fields. And then when you actually go to use a fragment in a query, you basically just replace where you had previously written out all the fields with the name of your fragment, and the 3 dot is actually the operator that tells GraphQL this is a query, this is a fragment. It's not like I'm saying there's other code here. You just put 3 dots in the fragment name. And then when you run the actual query, the response you get back does not have the name of the fragment in it. Like I said, the fragment is private to your client-side application, not passed through to the schema anywhere. So if you have the same name in the fragment in multiple versions of your app, and every single version the fragment is different, that's fine. Another operation that you can do other than just querying are mutations. This is when your client pushes changes up to the server. So very equivalent in REST when you're doing like a delete or a put or something like that. And we want to run those through GraphQL as well for consistency. It also helps with like offline mutations if you're making changes locally that you want to sync with the server. Running everything through one source of truth makes things work a lot better. So we have support for this. You have to use the mutation keyword, arbitrary name after that. And then we have variables and arguments that work much like the queries. And then at the same time, you can define your response, just like with a query. So what you want to get back after a successful response is also up to you on the client. And we are sending the variables that get embedded into the mutation separately as another JSON object. And then the response you get back, again, matches up with what you requested. So those are kind of the primary language constructs. And then I think there's just one mindset shift with GraphQL, which is around versioning and backwards and forwards compatibility. So you generally don't need to version endpoints in GraphQL. I think Facebook might only have one version of our GraphQL schema. I don't actually know that for a fact. But you will no longer be debating whether or not it's time to rev your API or like, can we make this change, or not. And that's because clients use the types in different ways. So as long as the types on the canonical server schema support what your clients need, you don't need to version anything. And adding fields is really cheap. Of course, if you properly configure any JSON parser, it will ignore fields it doesn't know about. but you're still sending them over the network to your phone, and that is degrading your user's battery. So in this case, if the clients are not asking for particular fields with their fragments, then they'll never get them at all. So you're not wasting anyone's battery or extra bandwidth or things like that. There, of course, are still some breaking changes. If you change types very dramatically or something like that, you might want a version. But generally, you can get away with just adding more fields and relying on the clients to take care of it. So hopefully you're now getting excited. Maybe this is something that'll work for me, but you want to play around with it. You're not going to convince everyone in your company to flip over to GraphQL tomorrow without having done an experiment, and you need a backend for that. The good news for that is there are some existing public APIs. You don't need to build anything to use these. So the first one, and where all the examples are coming from in this talk, is the Star Wars API. It's actually an open source REST API that somebody built. And it just has a lot of nice resources to play with. But then the GraphQL team wrapped that REST API with a GraphQL API. So you can actually compare both. You can make REST calls, you can make GraphQL calls, compare them. You can also look to see how we wrapped it. That's open source as well. But perhaps the more exciting news is that only a few days ago, GitHub announced that they're going to have a public GraphQL API. This is a really big win. They put a huge amount of effort into making their REST API one of the best in the industry, and I always thought of it as like a great example of what to do in REST, and so I'm really looking forward to them applying that same level of polish to their GraphQL API. I suspect, it's very new, it's early release, but in not very long amount of time, this will be the gold standard for what people are using in GraphQL talks. If you do want to go all in and build yourself a backend, there are already GraphQL server libraries for most major languages. The JavaScript one is the reference implementation from Facebook, so that's probably the most polished. The Ruby version is the one that GitHub is using, so I suspect that will also get very polished. And then the rest of these are community-driven efforts, various levels of spec compliance, and you can look at the one for your ecosystem and make a decision. But I actually think the easiest way to dabble in GraphQL is to not actually replace your backend, but to wrap your backend. So assuming you have an existing API, REST or SOAP or whatever you have, you just build an interface that stands in front of it. And there's a library produced by the GraphQL folks called Express GraphQL. It's an Express Node app that's really good at proxying calls from GraphQL to an existing API or multiple APIs. So this is a good way to wrap various services. Or if you have like a microservices backend with a bunch of different ones, you could have one Express GraphQL like backend for front end as a proxy in front of a series of backend apps. And then you would probably want to write this incrementally on a particular resource and start moving your apps over, a little bit at a time until they're fully committed. So I'm not going to dig into how to do this too much, but I would highly recommend the video 0 to GraphQL in 30 minutes. This is by Steve Luschner. It's really, really good. He gets through writing a backend, I think, in Python and Node in 30 minutes, and I'm not even getting through this in 45, so impressive. And then there are the Express GraphQL project and also Graphical, which was the tool that I showed earlier. So as soon as you wrap your API with Express GraphQL, you get that tool, Graphical, in the browser immediately, no extra setup required. So both of these things are really useful. All right. Now we get to the heart of this, which is that all sounds great. It all sounds very magical, and that's what I always thought when I was watching these talks as somebody outside of Facebook, or even once I was in Facebook and started using it. It felt very elaborate and amazing, but like, well, how would you even start, right? And the rest of this presentation, I hope, is to just pop the magic. Like, there is nothing crazy going on here. So the first question is, like, why are so few people on Android using this? And this is basically the bad news slide. So there's a very vibrant community around Relay, which is a web framework, and that is using GraphQL, and that is why there are so many backend libraries for GraphQL, because there's plenty of people doing React and Relay and all this stuff, and even React Native using Relay. And there's also a company named Apollo that's building like a separate stack of GraphQL SDKs and libraries and frameworks, but they also don't have an Android one yet. They have an iOS one recently, and before that it was React and Angular. But as far as I can tell, there's no open source Android clients. I hope somebody tells me I'm wrong, but I Googled pretty hard and couldn't find anything. And so I think the reason why this hasn't caught on in Android is simply nobody sat down to write like an example of what to do. So I hope to walk through that in the next few slides. So realistically, what do we need to build? Well, we need to execute query requests and get the responses. I chose to build them around OK HTTP. I think that's the community standard at this point. You could work with a higher level framework like Retrofit or Volley, but honestly, I didn't want to put too many dependencies on this. And then the responses are encouraged to be JSON, and so you can use any library. I use JSON in this one because it's pretty easy to use, but Jackson's totally fine or any other alternative. The number one key point I'm trying to make here also is you should build around the GraphQL fragments. And this is worth its own slide. So the types that we define on the schema on the server are very analogous to what you probably consider types today on your REST API. And you're probably used to taking those types and then just turning them into Java models on your Android client, or maybe a subset of that model on your Android client. But basically, that's not how you want to write your GraphQL code. You want to start with the fragments you're defining on the client side in your queries and turn that into Java code. So if you were to do type models where you start with the full-blown types, you'd have one Java class in your app per GraphQL type. With fragment model strategy, you'd have one Java class per GraphQL fragment in your app. So there's a couple reasons why you want to do this. The responses you get back will better match the objects you have in your app. If you work off of types, like half the fields will be null, and it will depend on which query fetched that particular type, and that's not going to be really easy to reason about. And also, of course, smaller objects are easy to work with. So working from fragments, you get more objects, and each one is smaller and probably closer to its actual use case. And just in general, you want to encourage the use of fragments because it helps or avoid duplication, avoid overfetching, those kind of things. So looking at the most basic query I think I showed earlier, we want to go from the query that the client defined on the left to the response on the right. How do you actually go about this mechanically? So we need to make a GET request. It's going to be against the root of your API. There are no more URLs like a REST API would have. And then we just append a query string. Query is the param, and then you flatten out the query. Actually, you don't even need to strip the white space. I did for clarity, but it just needs to be URL encoded. And that should work out just fine. So in OK HTTP, you point at, this is the actual URL for the Star Wars API if you wanted to follow along. And then we just embed the query parameters into the URL. And when you execute it in OK HTTP, you can do it synchronously or asynchronously. That's kind of outside the scope of this talk, but pick your favorite method of filling that in. And that works. That's an easy way to get started in terms of simple queries. I don't think it's the most maintainable strategy. So there's an alternative, which instead of using query strings, you can use posts and multiple objects. So in this case, we're going to post the query that we have at the top and then separately pass in the arguments as another object. And this lends itself better to how you would actually structure the Java in your application. So we're going to pass this variables object entirely separately. So here it's now a post to the root of the API. It's not a get, even though you are fetching. The reason for that is so we can attach a body. The body has to comply with this actual structure. So the operation name is optional, but I recommend adding it for logging reasons and things like that. The query is, again, the actual structure that you wrote on the client in GraphQL language. And I stripped it of white space here for clarity. That's optional as well. And then the variables are attached just as a JSON object. So in OK HTTP, we're going to, again, point to the base URL. This is a small note. The question mark at the end appears to be required by Express GraphQL. I don't know why. That took me an hour to figure out. So you also set the content type to JSON. We use the defaults for JSON. There's nothing special in the response you get back. And then when you actually send your request, you can just use the base URL for everything. And we encode the body object to go along with the request to trigger everything properly. And this query here is no longer a string. This query is an object. And that object provides these three JSON fields. So again, operation name is optional, but query is not, and variables makes a lot of sense if you have them. Oh, sorry. So I've talked a lot about fragments, but haven't shown you how to actually use them in these operations. So imagine that we are using the description fragment on film. I don't know why I changed names here, but that kind of makes the point. Fragment names don't matter. The query that you send to the server is simply the entire GraphQL query and all of the fragments you referenced concatenated into one string. So the query object in the body of your post is going to just take together all the fragments and all the queries and stuff them all into one string and pass that along. And that's what the server unpacks in order to prepare your response. So what does that response look like? Well, so far I've been omitting, there is a wrapper around everything. So at the root of the response, there's a data object and there's a list of errors. So the data object is not present if any errors occur before the query execution. So basically the first step that the GraphQL server does is unpacks your query and tries to parse it. If it doesn't even get through that, then you won't see data here, you'll just get errors. If it does unpack it completely and starts to execute the query but can't get all of it, you might have some data or not, kind of depends. And then the list of errors is just omitted if it's, if everything's successful. That doesn't matter too much, except just make sure, like I have a GraphQL response class that's like a wrapper. Just make sure when you configure your favorite JSON parser, it can handle null here. So JSON, Jackson, those kind of things, make sure these handle those optional cases I mentioned. Let's go back and dwell on failure modes, because engineers love failure modes. So there's one additional one that you probably are not used to. So network connection, nothing we can do about it. GraphQL does not fix physics, so we still have all of those standard issues. And you can still have all the server errors that you would normally expect, 400s, 500s, whether you're having server failures or not authenticated, you need to handle all of that as well. But there's another class of error that GraphQL has that you don't normally see with REST APIs, and that's GraphQL execution errors. So if you make a syntax mistake in your query that you send to the server, you'll get a response back that spells out the error. There's also issues if you ask for a type the schema doesn't include, things like that. So there's a bunch of different GraphQL specific errors, but it's a whole other class of error you need to make sure you handle in your logic. The error response format looks a bit like this. It's a list of errors, you'll get multiple. Each of those errors itself has multiple locations, so if you make the same typo over and over, it'll list out every one. The message is relatively human readable. This one is telling me that I misspelled a field. So generally you can debug it pretty easily that way. And going back to that tool Graphical in the browser, I basically do all the queries in Graphical until I get successful responses and then worry about bringing them into the Android app. So you're basically seeing these in the browser and then pulling it over. So again, this is a suggestion, not a requirement, but this is how in the sample app I put together, I structured the responses. So I have an error class. It has a list of error locations. JSON parsing all of this is relatively straightforward. And then you can get nice objects around all of your errors when you're building your application as well. In the happy path, when you actually have a successful response, you basically just need to pull the wrapper off and you will get the structure that you asked for in the query. So that means that the responses match up with the requests and you basically need objects for both. So I usually have one response object for each basically query type. And there's also other classes you need to fill out for the fragments you asked for. So this gets into kind of arguably how do you structure the code in your app. And I think that's open to interpretation. But assuming you have like one class for each fragment, you need to embed that into the response and so on and so forth so that you have like objects for serializing and deserializing everything. And I'll circle back to that in a bit. In OK HTTP, it's pretty straightforward to parse this stuff. The only gotcha is you want the string method and not the toString method on the end of the body, minor note. That's the only reason for this slide. In terms of actually parsing, this is what retrofit does for you, or volley. So if you're used to like the beautiful type returns in retrofit that we know and love, this is what it's hiding from you. So you can use something like that to get away with it. I'm sure we can work something out here, but this is actually creating a type token for the response wrapper, for the actual response class, and so on and so forth. It's basic JSON parsing stuff. It's just ugly. So in general, what do you actually need to put in your app, right? So I think you need wrappers for the primary GraphQL responses, the errors and the successful ones, and you need something that knows how to execute the queries. And then for your application, you're going to write a bunch of fragment models specifically to the fragments you're asking for, queries that line up with the queries that you're actually sending, mutations if you're doing those, and then responses. So this ends up being a bunch of things that are really enabling JSON parsing and a little bit around eliminating just dealing with strings all the time. So where do we go from here? Assuming you follow along this talk, you can execute basic requests and you can actually parse the responses and get data, and you could build an app this way and it would work. But there's a lot of boilerplate, and I think we can do better. And if you do that a couple times, you'll see there's just a lot of repetition. So code generation is the right answer here. We believe that you should write GraphQL and generate Java. This is very different than the way most Android systems eliminate boilerplate. There's lots of great libraries. There are annotation processors that go from Java models to more Java code. But GraphQL is a language specifically designed for its purpose. So trying to write Java and annotating it to go back into GraphQL is probably a leaky abstraction. So we think that just write out the queries and then parse them and generate fragments, queries, mutations, responses, all those things from that is a winning strategy, not the other way. So if you're interested in looking at that, there are a couple starting points. You're not totally starting with a blank slate. So GraphQL.js is the reference implementation in JavaScript that Facebook has open source. It actually builds an abstract syntax tree of the GraphQL schema that you can use. And it's also the basis for everything that Facebook does for code generation, so it's well maintained. And that's really nice. But I'm personally not very comfortable in JavaScript. If you are like me, most Android developers maybe prefer Java. There's an open source project from the community called GraphQL Java. This is built around Antler. It's likely not as compliant. There's a warning on the README, but I looked at it and it does a reasonably good job. So either one of these might be fun if you're interested in maybe after you've got a feel for the system and you want to try out different strategies for code gen. Either one of these would be a good starting point. I also haven't talked about a lot of the deeper things, right? So, I promised a lot up front about how this was going to make your life better, but really I've described like hand rolling some very basic stuff that you currently get for free from whatever framework you're using. The most obvious of these is client-side caching, whether you're using something like Volley or Retrofit or even just like the typical HTTP caching. You need something. So this is not clearly defined in the GraphQL spec, but basic request and response cache is pretty simple. You just basically use the arguments that you're sending up, which is the queries and the fragments and the variables. The tuple of all of that is your key. The value is the response. You can build that really straightforward. The spec also mentions globally unique IDs. So every single edge returned from GraphQL gets a unique identifier, and you can cache those. The reason why these are not specified 100% is because they're hard to generalize. Different companies have different business logic around IDs. They have different rules around their caching logic, and these are kind of like higher order problems that the GraphQL spec is not intended to solve. So rather than spec them out just yet, we have a set of best practices and recommendations. They cover pagination, authorization, which was completely not covered in anything I talked about here, but is relatively interesting when you no longer have routes. Batching, which is just an efficiency gain, but it's covered in there. And these are all on the graphql.org website. And there's a section under best practices. Honestly, just read the whole website if you're interested in this. It's a good read. I don't know. Don't want to tell you. So these are my concluding thoughts. And I guess there's a little bit of context here, in terms of my experience. So I wanted to write this talk before I started working at Facebook. I've only been at Facebook a while. I was on a small team of Android developers, and we also did the backend for front end that powered our iOS and Android app, and I was building all these backend things. And GraphQL sounded like the silver bullet to fix it all, and I saw a lot of great talks explaining the benefits, but I didn't know how, right? And so writing this talk was a process of me figuring out how do you do it with none of the Facebook infrastructure. So the key takeaways that I had from that experience was that the lack of open source libraries for Android hurts. You're writing a bunch of stuff that you get for free if you stick with REST. But it's not actually very complicated to implement. If I had realized this when I worked at another company, I would have done it there. So I'm hoping that I've like popped the mystique around it, and some people decide like, hey, this is worth a try. It's a really nice win, I think. So, and I'm really confident that once the libraries exist, but also just the knowledge in the community, and there's people to talk to about it, I think you're going to be a lot more productive with GraphQL than you are with like the ad hoc REST APIs we're all working with today. And I really think that tooling and validation is a game changer. I'd love when I had Swagger on my API so I could just enter things in a browser and play around and not have to mess around with curl. Graphical is like everything in Swagger plus more, and I think that's great. And getting validations on whether or not your queries are going to work before you even execute them is very nice if you're into testing, if as much as I am, as much as you know. And I think long term, you'll obviously get resistance if you go to your backend developers right now and say, hey, make me a GraphQL API. But the long-term gains on reduced maintenance, I think, will pay for the learning curve of figuring out this new system. And there are a lot of libraries for the backend. So the upfront cost on the backend is not that bad. And then long-term, we're going to eliminate a lot of low-value work. And so I think that really works out for the whole team. So next steps, if you're interested in this stuff, what do you do? Well, the very first thing, some of you already have your laptops open. You don't need to install anything. Go to Graphical on the Star Wars API and just play with it. There's no sign up, there's no authorization. You can start making requests and look at documentation and see, get a feel for it. And then if you decide that makes sense, I'd say the next step is start wrapping your API, maybe one resource, something like that, and build an Android side to match. So I would start with Express GraphQL, and when this talk is on YouTube, pull the bits I saw out of it. But actually, if you don't want to wait for that, the spec covers all of this stuff. I did this basically all off the spec. And finally, I really encourage you to join the community. There are a dearth of Android engineers on it, but there's a lot of people using this for backend and relay. So take a look at graphql.org. There's everyone's favorite mechanism, whether it be Slack or Twitter or Facebook groups or Stack Overflow tags. Like we have community in every direction. So join the community, look at the open source projects, and thank you. I hope this interests you. I hope you guys get some value out of it, and I'd really like to see in a year what the community looks like around GraphQL. I'll take questions. I also know lunch is coming up, but if anyone has questions.
Are there any extensions for like plugins to, for example, I know with Elasticsearch you can do a location search like based on coordinates. Is there anything along the lines of that?
I wouldn't say that there's anything along the lines of like plugins per se. I think that there are like higher level frameworks built on top of the language. So Relay is a good example of that, where that has an opinion about caching and pagination and those kind of things, and it uses GraphQL as a foundation. If you want to do something that was like GraphQL plus location, then you could build that on top. In terms of like, is there a type for location already? I don't think so.
What's the backend database?
So there's no implementation. It's not like this is a backend as a service. It's not like a couch-based alternative, right? It's a language that you use in between your front end and your back end. However you implement the back end is totally up to you. So actually, if you look at the wrappers, what they do is when they get a request, it basically peels through the fields and makes another request for each one of those fields. So one type can cover over multiple APIs and then coalesces them back into one response to send down to the client, which makes it really ideal for covering, if you're hiding a bunch of old style APIs, it's actually a really good way for converting, like XML or SOAP or something like that to a more mobile-friendly kind of format.
Are there any like performance concerns if you're trying to migrate like a REST API backend to maybe a GraphQL backend?
So I think other GraphQL talks might have talked about that, but I mean, it's a little bit implementation specific, obviously. I mean, I'd argue that you're doing less work, because if you're only fetching the data that you exactly need, like you're probably already doing a bunch of fetching out of a database that you don't need to be. So whatever overhead there is around parsing GraphQL queries, you're gaining by not doing that extra work. And then there's ways to optimize this over time. So like this is the very much beginning, how do I use it at all? But as we dig into it, there are ways to optimize all sorts of things that you could get to.
How does this compare to other frameworks and API specs like JSON APIs and whatnot?
Yeah, I would say it's a different approach The thing I like about Swagger and JSON API is they're solving the well-specified problem. So like if you look at the way a lot of people implement REST, they reinvent every wheel. And that's just not useful. So JSON API, Swagger, things like that, API doc, they all intend to lock down an example of REST that is interoperable. And I think that if you're doing REST, you should use one of those things. I think the key difference around GraphQL is a much bigger emphasis on the client drives the contract. So the client determines what response you get. So even in like most of the REST frameworks, you're agreeing on content types on both sides, which means the server needs to know like what content type you've defined. And in GraphQL, the server doesn't at all. And maybe this is just an advantage at a large company, but like in a lot of cases, people are coming up with GraphQL queries at Facebook, doing all sorts of things that the backend developers like never even knew where they were going to be used for, and you can just like merge things together. So you're decoupling the front end and the back end more in GraphQL than you are in like a REST framework where you need to agree on a new resource or something like that. But I think all of those frameworks, whether they're JSON API, Swagger, API doc, are highly valuable and are way more polished than all the open source GraphQL stuff. So like if you're talking about what am I going to get more out of tomorrow, that's definitely a good way to go. I think what has potential in the long term, I think GraphQL has a lot more potential in its approach.
Have you tried to use GraphQL in like WebSockets or something like this without making many separate requests?
There is. I didn't cover a couple more advanced things in GraphQL, but there's something called GraphQL subscriptions that are very much like that. And you can actually have like pushes coming through GraphQL. There's actually a lot of stuff in the spec that's kind of higher level, but I wanted to start like really low basic stuff here.
Okay.
Yeah.
What about like creating entities on the server? Like, does GraphQL is all geared for reading content, or does it give you tools to like, say you want to like kind of coalesce like a bunch of different entity creations that are all tightly coupled all at once? Like, does GraphQL allow you to push that to the server so the server can parse that apart and handle that?
Yeah, so that's called a mutation. I really briefly covered it, but like basically that's the, a query is pulling and a mutation is pushing. So you can do mutations to really pull off anything like that. And also you mentioned in there like server definitions. I think it's also interesting. I defined all the types in the IDL language, but if you look at most of the libraries, the types are actually defined programmatically in the language that the backend's written in. So that's kind of like a little bit of a different twist on it as you dig into it.
In terms of like express GraphQL stuff, going to wrap your existing API, for instance, how do you like sort of make sure you cover all the cases? Maybe that's in the express GraphQL documentation, but like if you just have like simple get API, it seems like a lot of edge cases you could potentially have to handle.
Right, so the question was basically the mechanics of how do you wrap your REST API with a GraphQL API. It's tedious, but if you look at the GraphQL, like 0 to GraphQL in 30 minutes talk, he goes through, but basically you line up every single field in your type makes a network call. Or a type makes a call or whatever, and you pull things out of it. But you basically get the REST objects in and then define mappings from your REST objects to all the GraphQL fields, and just make sure you cover every single one. So testing, tedious, sometimes you just got to do that stuff. Yeah.
If you would implement GraphQL on backend from scratch, would you, like, if client wants some subset of fields, would you even pass to the database this information to extract this very few fields?
That I would say that's like an implementation detail of the backend, and I think some of the different libraries handle it in different ways. But like obviously, the better you optimize that, the more gains you can get.
But for example, at Facebook, do you do that?
I actually don't know.
Okay.
I'm an Android developer, and like I use GraphQL, but the implementation of it is not something I know much about.
Building all the queries and mutations, I see that GraphQL doesn't follow the JSON format. Is that something we have to do manually?
Do you mean on the like writing the query?
Yeah, exactly.
Yeah. So the query that you're writing is GraphQL, the language, right? And so so what we do is we write that in a separate file with like a GraphQL extension on it, and then you code gen from that to Java classes. But what I did for the sample app was I literally just wrote them as string literals, and I just passed them and flattened them and things like that. So I just have a bunch of string literals. It's a lot like dealing with SQL. So, there's a strategy of like just write SQL and pass them around as strings, or like ORMs, which we don't think is the right answer here because the language was defined. I have the same opinion about SQL, so maybe that's why. But basically treat it as a string. And then if you want to go one step further, treat it as a file that gets turned into Java.
In terms of requests and responses, have anybody in the community tried integration between the Thrift and GraphQL?
We sometimes use some other binary formats instead of JSON, and the specification encourages JSON, but it doesn't require JSON. So, you could think about this in terms of like the fragments cut down your response because you're only passing the exact information you need. But then how you actually transfer that over the wire is like a different layer in the stack. Like JSON's nice, but it could be any binary format you want if you wanted to do that, and that would be tighter. Yeah.
So with something like protocol buffers, you would be having code generation in 2 places.
Yeah, and we do. Yeah, there's a lot of code gen, but if you get to the point where that's the limiting factor, then sure, it's worth it. But I think in my experience, like cutting the request and response down to solely what you need for the client and then gzipping it gets you pretty close. Like you can squeeze a little bit more out by going to a binary format, but I feel like for most people, the combination of cutting down their responses to exactly what they need and gzipping will get you like 85% of the way there with none of the pain. One of my previous apps, we did binary protocol back and forth between the server with a small team, and like the edge cases that we encountered were definitely not worth the cost. So, any other questions? Cool, thank you. I'll be around.